In this video we're going to talk about how to estimate a square root to the nearest integer. So let's start off by making sure we understand all the words here. We've got square roots and we have the word integer. So let's start with integer and remember what integers are. Integers are the numbers that don't have fraction parts and don't have decimal parts. So this is the technical way to write out the integers. The set of all numbers coming up from negative infinity. It includes negatives. And so we got negative 3, negative 2, negative 1, 0, 1, 2, 3, and all the way up this way. So 4, 5, 6, 7, 1082, that's an integer. And then the opposites of those numbers all the way down here, negative 4, negative 3, or negative 5, negative 6, all the way forever. So we're going to estimate a square root to the nearest integer. Now let's talk about what a square root is. A square root symbol looks like this. And I like to think of it when I'm drawing these three segments here, 1, 2, 3. I like to think what times itself. So if I see square root of 25, what that's asking me is what times itself is 25? And the answer is 5. Okay, so there's a lot of these questions that come out nice, and this is one of them. What times itself is 5? The square root of 20, or what times itself is 25, which is 5, the square root of 25. Let's make a list. Let me get rid of this, and let's make a list in order of all the ones that come out nice, starting with 1. So we've got the square root of 1. What times itself is 1? Well, that's 1. The next nice one is 4. What times itself is 4? The square root of 4. That's 2. So you should kind of be thinking ahead here. What's the next one? That's going to be nice. The square root of 9, which is 3. Now we know the square root of 9 is 3. And then the flip side of that is that 3 squared is 9. So squared and square root are reverse of each other. Here, let me write that down just to kind of make that point. So if the square root of 1 is 1, then 1 squared is 1. If the square root of 4 is 2, then 2 squared is 4. And the square root of 9 is 3, then 3 squared is 9. So square and square roots are sort of opposite of each other. Okay, let's do the next one. What's the next one going to be? Square root of 16, which is 4. And then we know 4 squared would be 16. And the square root of 25 is 5. Next one, square root of 36 is 6. So to find the next one, I'd have to think 7 is going to be the next number here. So 7 squared is 49. So square root of 49 is 7. We'll go up to 10. Square root of 64 is 8. Square root of 81 is 9, because 9 times 9 is 81. And square root of 100 is 10. Now these you should really have memorized as perfect square roots that come out nice. And we could keep going. The square root of 121 is 11, square root of 144 is 12, etc., etc. But we're not going to. Okay, so knowing these is going to help us to estimate square roots that don't come out nice. Let's say somebody asks me, well, what is the square root of 26? Well, I don't know, nothing times itself is 26, but I know the square root of 25 is 5. So what I want to do is think of a square root close to 26. I know the square root of 25 is 5, and I know the square root of 36 is 6. And the square root of 26 would be between those two, so the square root of 26 is going to be somewhere between 5 and 6. Okay, is it going to be closer to 5? Is it going to be closer to 6? Well, 26 is closer to 25 than it is to 36, so it's going to be closer to 5. It's going to be very, very close to 5. If I had to guess to the nearest decimal, to the nearest tenth, I'd probably say like 5.1 or something. But if it wants me to estimate to the nearest integer, then instead of using an equal sign, let's use a approximate sign. It'd be approximately 5. That would be the estimate to the nearest integer. So let's bring in a calculator and see what the square root of 26 is, according to the calculator. Let's see, 26 square root 5.099, so it's pretty close to 5, isn't it? If rounded to the nearest tenth, it'd be 5.1. Notice this number it doesn't have any repeating patterns in it. As a matter of fact, it goes on forever. Even though the calculator is only showing us the first whatever 10, 11 digits or something like that, it does go on forever without a pattern. That makes it an irrational number. All square roots that are not nice, all square roots that are not square roots of perfect square numbers like these are going to be irrational numbers, which means their decimals are going to be non-repeating, no repeating pattern, no block, and non-terminating, which means they're never going to end, even though the calculator's not, showing us only however many digits it can hold. All right, let's try another one. Let's see if we can estimate to the nearest integer the square root of 78. So what you really want to do is look in your list here and see where that would fit. Where would the square root of 78 fit? Well, it looks like it would fit right in there. The square root of 78 between 64 and 81. So let's write those down over here. So we got the square root of 64, which is 8, and the square root of 81, which is 9. So it's going to be, the square root of 78 is going to be 8 point something. Is it going to be closer to 8 or is it going to be closer to 9? Well, look at 78. Is it closer to 64 or is it closer to 81? It's definitely closer to 81. So if I had to round this to the nearest integer, I would say it's going to be about 9. If I had to round it to the nearest tenth, I would say 8.8, 8.8. That's a good guess. Let's see how close I came here. Let's bring in the calculator and check it out. 78 square root 8.83. So, estimating it to the nearest tenth, is kind of a little bit of guesswork, just depending on how close it is to the perfect square. But certainly estimating a square root to the nearest integer can be done with 100% accuracy, pretty much, just by determining, finding your two perfect squares, the next perfect square that's above it, and the next perfect square that's less than that number, and then determining if this number is, which number this number is closest to. Is it closer to the one that's less than or closer to the one that's greater than, and then going with that answer. So hopefully that helped, and you'll have a lot of success in estimating square roots to the nearest integer.